Hello, good evening to all the participants. Welcome to all from Team Bob Builder. Today there is a second part of what we you have learned till yesterday. So in the Sunday special webinar, which was a combo webinar of session 1 and session 2, we have learned till how to create a geometry, how to assign properties. So basically what you have learned is so the Sunday special webinar, which was a combo webinar of what you have learned till now is how to create a geometry using various commands such as nodes, members, translation repeat, circular repeat, etc. and how to intersect the nodes. Then after you learn in the general tab how to assign the properties, how to create the sections and how to see the rendered view. Today's webinar will be focused on first thing is how to create load cases, how to assign those loads according to the members, and after that your model will be ready for analysis and design. So we'll be going through the process of analysis as well as design, and after that you will understand how to interpret the results as well as the design report, which will be an output file in Staad. So before starting the webinar, I have some instructions for you people. If you haven't installed the software yet, I will strongly suggest you to install it as soon as possible because you won't be able to practice as soon as you don't uh, install the software. As well as if you don't install the software right now, you won't be able to do the steps along with me. So while webinar, I kindly suggest you to have your laptop open and do the steps as soon as I'm doing it. So, and the last instruction, if you have some doubts or queries throughout the webinar, feel free to post in the comments or live chat section. Don't hesitate to put on any kind of comments or queries. We are always ready to help you. I hope you will enjoy today's webinar. There are some important things about the webinar. Today's webinar will be conducted by a few junior T peoples. Out of these, two are the girls and one is a boy. So from now on, I'm giving the control to the Dhanashri Patil. So he will be conducting the webinar from now on. Sorry, she will be conducting the webinar.
Hello friends, this is Dhanashri Patil. Today I will be conducting your webinar. Go to Staad Pro. Go to Staad Pro software, open it. Today we'll have a new project. So select new project. Okay. So select space and check whether you have created new file on your desktop. Please the select structure name. Select the unit, that is meter and kilonewton. Then go next. Add beams and then finish it. So we got a mesh grid here. Today we'll revise what we did in the first seminar. First cancel this grid. We'll work with the nodes. So select node and we'll draw one triangular structure today, triangular tower. So I'll give the nodes. First take it 0, 0, 0. Next you'll take it 5, 0, 0. We got two nodes over here. Then third node, the 2.5, 0, and last I will take it 5 again. Okay, so we got these three nodes. Now we'll connect these nodes. Go to beams, beam cursor, then add beam. Connect those nodes. Okay, these two are connected. This is last. Okay, so we got this connected. So we'll see this top view. It's front view. It will be a straight line. and this is the thing. So we'll select all whole structure, then select all. Then now all the beams are selected. Then we'll use the command translation repeat as we want a triangular tower. So tower in vertical direction, so we'll select Y. Number of steps you can take as many as you want. We'll take 7 today. Spacing, we reduce the spacing 3 meter. And yes, don't forget to link the steps as this is a tower and it should be in a geometry. Otherwise, if you don't do this now, afterwards you need to link all those and it will be tedious work. So we'll link the steps and then okay. So we got this. Now our tower is ready. Go to front view. Okay. Now we'll select these sections for whatever to assign. So this is the structure, right? Go to geometry. Sorry, go to general. Then material. Now geometry, we got the properties. Then select section database. Okay, so like as Indian codes, we'll refer Indian codes. So we in this triangle we have columns and the triangular beams. So in this for the columns we'll select channel section. So I'll be selecting ISMC 100. The material is steel. Add this. See on the right side, this is added in your property block. Then next for the beams, we'll take angle section. I would like like a 45 into 5. Material is steel. Add it and then close. So we have the materials which are going to assign, but we don't have the groups right now. So go to front view. Now I'll select the beams. Okay, now I'll select this beams. The beams are selected. Then press Ctrl G. Then we'll give the name beams. View. As those are beams, we'll take the property. Select type beam. Okay. So we have selected the geometry already, the beams. So associate this. The beams are assigned now. Okay. One more thing I forgot means the one side is not selected, so I can select it manually also. I'll select those and I'll create a new group. I can delete this group. Select, delete. Okay, I think I've mistaken once again. I think I need to select all the beams again. Keep on selecting. Thank you again. Okay, this are selected. I'll select again. I know this got a little tedious. You can do it by another method also. You can first select the columns and you can go by inverse method. So these are selected, then Control G, group, give beams. So, this is beam. Okay. Associate to selected geometry. Associate. All these beams are assigned. Yeah. Go to geometry. Go to select beams parallel to the axis. All those columns will be selected. Control G. Create one more group for this. We can take it columns. Oh, select the type B. And okay, now new column is made. New group is created. Now associate to selected geometry. The columns are already selected. Then associate. Now the beams are assigned here. So I'll assign the channel section to the columns. I have selected the column group, this material property, then assign to highlight, highlight those columns we have selected, channel, assign to selected beams, and then it's assigned. An assignment, yes. Will now this channel section is assigned to the columns. Now select beams, whatever the triangular group we have created, highlight those, select ISA. Okay, it went again. Select the angle section first of all, beams, highlight those, then assign to selected beams and assign. And yes, assign the selected beams. Now the properties assigned. Now we will see the render view of this. So, just a second. Cancel this right now. Now these columns are channel sections and the beams are angle sections. You can see in this view. Okay. Okay. This is one. Now we go back. Okay, I'll select this section and we'll see its render view. So this is zoom it. So you can see this. Okay, see this. This is an angle section. This is an angle section which was selected. Okay, we'll cancel it. So in the render view, whatever section you have assigned, we can see it more clearly and more properly. Whatever section we have assigned and how they are connected. Now, now, now next procedure is to assign these supports. Obviously, yes. Assign these supports. Go in general. There's support. Go to front view. Select nodes. Now create the support. So if it is fixed, then yes, already the properties are given. Yeah, all 6 degree of freedom are restrained, so it is fixed. In case you want a simply supported or hinged, then such option is in enforced, but whatever the structure you want to release, if it is a simply supported beam, then you need to release it at fx, and if you'll add, then you'll get support. This is simple support, but I would prefer fixed support for this, so I'll add this fixed support. So, and second, I don't need this right now, so I'll delete it. Okay, so now support, select 3, go to nodes, select the nodes, check whether your all 3 base nodes are selected. Yeah, they are selected. Now we have to assign the supports to them. Select support 3, assign to selected nodes, and assign. Now the supports are assigned. Cancel this. Now the section property is done. Loads are assigned. Now we'll learn how to assign to load, means how to put on the load on the structure. Go in loads and definitions. In general, you'll see three things on the right side table: definitions, load case details, and load envelopes. So in definitions, you'll find many definitions that are vehicle, time history, wind. All this, all this are types of loads that we can apply. Mostly seismic definitions are used for the earthquake testing. Then second option is load case details. So click on this, add whatever load you want to add. Load case 1, its loading type. Obviously, every structure has its self weight. So self weight. So we'll give a load, we'll assign a load, then add it. See, in the right side it's added. Second, we can define as many load cases we want. Again, we'll give live load. We'll put live load to our structure. We'll load case 2, then add. As both are added, cancel this. Okay, so load case 1. Load case 1 will add the self weight. Here, dead load, self weight. As the self weight acts in downward direction, we'll take it -1 self weight, then add it. Load case 2 will add load case 2 will add some nodal points at the top section. Will add suppose -30 kilonewton. In y direction will add -70 kilonewton. Okay, then add, cancel this. Self weight. Now self weight, every member has its self weight, so we need to note, instead of selecting we can just select the self weight. Right now there is a question mark here. If we'll assign, then we'll get a cubical thing over there instead of question mark. Now self weight is selected. Assign to fifth means all the members will be assigned by the self weight as they have their properties in IS code. Self weight assigned to view. Assign. The structure is assigned with its self weight. And here also there is no question mark right now, means yes, we have assigned it. We can cross check over it there. Then it is next is nodal point. This nodal point, we need to select the node. So I'll select this node. I've selected one node for this. Just a second. Assign to select, then select this, then assign to selected nodes, and then assign. So now we have assigned. So this is the load direction in fx and fy direction. We have applied the self weight and also the nodal load at the top of the structure as if the wind is acting or any external load is applied over there. So close this. Okay, load definitions. Yeah, we forgot to take load. See what's load envelope. In load envelope, it is about the combinations of dead loads, live loads. We have taken two cases. So this case, next selected, then second load case is also selected, and add. Type. Okay, wait, forgot the type. Type. Let's check it none. Second load is also assigned and selected. Add those loads. This load combination will be acting on the structure. We have added two envelopes by mistakenly. We'll delete one. Okay, in load case, we'll also add UDL at the top. Load case 3 will take it roof live. Add this load. Yes, we added this. Now select the load case 3. Then we'll add member load on this UDL. So we'll add uniform force over here and we'll take it as 25. We'll take it as minus 25 kilonewton per meter as it will act in y, y direction, downward direction, it will be negative 25. Then then now select this, go to beam cursor. Now this 25 kilonewton load will add to all the members. So assign to view, select the load, assign to view and assign. Is selected. So now the structure at every member, the load is applied. Loads. You can see the loads on each member. The UDL we applied. Okay, so next. Okay, now the supports are assigned. Next, we'll analyze the section. Okay, so now this is applied and we'll analyze the section. Modeling. We'll run, analyze, we'll check. Okay, now we'll design the structure. Okay, we'll take 5 minutes break. We'll be back after some time due to technical issues. So we'll be back.
Okay, we are resuming after the short break. So we are assigned the section properties to the created geometry. After that, you could come to general here. You could see these are the properties which we have assigned. I'm just deleting this section number 3, which we haven't assigned to any of the members. You can see the section is deleted. We also assigned supports here, 3 fixed supports at the bottom nodes. And in loads and definition, we have created load cases. You could see here, you could click, we created 3 load cases, of which load case 1 is self weight. Load case 2 is a member loading, and a load case 3 is a uniform member load particularly. So right now we will go into the analysis and print part. So again, click here in the tab window, particularly analysis and print. Huh. Okay, before going further, wait a minute. I think whatever I told, the screen was not shared. So sorry, I did some mistakes. I will explain again whatever we have done till now. We have created a geometry. I think if you have gone through yesterday's webinar, you can understand it in much better way and efficiently and in a faster way. And sorry if you have some issues like webinar was a little faster, we will slow it down. Don't worry about it. So firstly, we created a geometry. Then we went to general and created properties. And then we assigned those particular properties to their corresponding members. After that, we created supports and we assigned the supports. And then we created load cases. You can see here load cases again. Then we are going to analysis and print. But before going to analysis and print, one of the participants had a question: what is a load envelope? Basically, when you create a load case, you create individual loads according to their it's a type of the loads, whether it's a dead load, live load, print load, etc., or a member load, node load. But load envelope is like a load combination. So you could create worst loading cases by creating a load combination of different load cases you defined. So in this particularly, now we are moving ahead with the analysis and print tab. So click on all, click add. You could see here when you click on add, on the right hand side window, you could see here perform analysis print all, and you could also see a green tick here. Again close. Now go to analyze, say run analysis, click save. An output file will appear here. In this output file, you could see here 0 errors, 1 warning, 0 notes. So either we can go to this view output file. So click on OK. You could see this is the output file. We are going to explain this output file after the design procedure is done. So till that, we'll again go to analyze, run analysis, and we'll go to post-processing mode. So this is the post-processing mode window. Now on, I'm handing over this webinar to Sagar Latwani. So he will conduct the webinar regarding post-processing mode and then explain you various types of displacement, reactions, stresses, forces, etc. This is the most interesting and most important part regarding result interpretation. So make sure you're quite attentive for this particular small part. So I'm handing over to Sagar.
Hello, people. I'm hoping that you're enjoying this session, and maybe it's going a bit fast, but you can ask your queries. Our team will respond to that. Okay. So till now, what uh, we have done the analysis of the structure. As you see, you design the structure at first, and then you go for analysis to check how the structure will perform under real life forces. So we have done the analysis, and we have got into the post-processing mode. You can see here various tabs are provided. We were in the modeling tab, where you can still change your design if you want to improve it and stuff, and then go for analyze to run the analysis of your structure. I'm running the analysis. See, some people might have some errors regarding their structural design, as in there are specific properties. Maybe some section is not provided and some stuff is not present, but we can sort it out. Now we'll go post processing mode. Okay. So post processing mode is the most amazing part. I especially like this arena. The reason being, you can see your structure under the forces. I mean, you can see the left pane. It consists of node, beam, animation, and supports, and it has displacement and reactions. Now, according to the loads or forces you're applying to the structure, they will deflect in particular direction, or you can see movement and bending and stuff like that. Now, go to post processing mode, and you can see a right side columns here. These columns are present for showing you the actual displacement in the structure. Now you can see the in the first table of node displacements, you can see there are nodes number given as in the first node, and you can see what particular load combination is applied as in because of load case 1. Okay. Here you can see for a particular node and a particular load case, how will the structure deflect, how will the node displace. So here I'm considering for node 1, and you are seeing for load case 1. If you remember, we have applied two loads, the self weight and UDL. So for the self weight at particularly node 1, how will that particular node deflect in the geometry? Now because node 1 was fixed, if you remember, the support, because of the supports provided, the nodes are not allowed to displace in space. So you can see that deflection in space is 0, 0, 0. Same case is for the second and third node. But when you go to the fourth node, you can see from the diagram itself that the first, second, and third load, they are fixed. So there won't be any deflection or any change in its position. But when you go for the fourth load, you can see its particular deflection. Even if you have noticed here, before you can see that 0, 0 isn't provided with a sign. But for the fourth node, even if it is 0, there is a minus signature over there. So it shows that it has the capability to move, but it isn't moving. Now, because of the application of load, this node has moved in space by 0.0037 mm. So you can see how your structure will deflect under the action of these specific nodes. Now it is because of the self weight for the load case 1. Now go for load case 2, and you can see a huge deflection because of the UDL that we have applied on the front. Now think of it this way, as in if there's UDL on 10th floor, then the 10th floor is going to bear the UDL of the 10th floor only. Ninth floor will bear the load of ninth and 10th floor, but the second floor will bear the load of every upcoming floor from 10th to second. So you can see it has the maximum deflection in that particular direction. Not just this, you can also see the rotational effect on that particular one. Okay, so this table is particularly given for node displacement. Now we'll go for beam related displacement. You can also analyze the relative displacement of beams so that you can analyze the structure in a better fashion. Now, for people like me who are more interested with the animation stuff, you can go, just a sec. Okay. As you are seeing on the screen, point is we'll be seeing animation soon, but you can see for different scales, there will be different deflections, right? So what I currently did is I had right clicked over there, and then I went to labels. In labels, we see option of scales. Now, for every particular kind of deflection or rotation or movement about certain axis, we shall see the tables here. Because of the point force, the displacement, these are all just scales. As in, if you change the scale, you can see the different scaled displacement or changes in rotation and stuff. Now, if you can see, I'm changing it. Now this is the structure. Under the action of given forces, it will displace in this particular fashion. You can see the initial position of the beams and the later positions of the beams. Even if you concentrate, let me zoom in. I am focusing on the nodes. Well, the students who have studied advanced structural dynamics, they know because of the fixed position of the nodes and the application of load, the bending moment or shear or displacement of the beam will be somewhere like this. See, this last part of the beam, which is connected to the node, it will deflect upwards. You can see that there's not a big difference, but you can still see it is noticeable if you can see this distance. Now, this is just for the nodes and beams. Now, some people would like to see the animation in action. So, are you guys up for animation? Okay. Considering that you are enjoying this, I'm going to animation tab now. We go to animation. And now for animation, you have to tell the software that which particular kind of displacement or rotation you want to see. So the diagram type has to be selected. So I want to see the deflection of the structure. So I'm going with deflection. And you can see animation or video is kind of a moving frames. It is moving photos. So you can go and define the frames. Now I'm defining is 24 FPS. Okay. And now I'm going to apply it and let's see what happens. If you can see, the structure is moving and displacing a little bit, but I want to see the effect to be magnified. So what I'm going to do is I'm going to change the dimension, the scale of the animation. So go to animation tab, go to scale and change the scale of the particular thing you want to see. Now here is displacement scale is 10. I'll reduce it to 1 and see what happens. Just a sec, I haven't selected it. Deflection, scales, displacement. Okay. So how amazing is it to see your structure in force? Now imagine if I reduce the scale a bit further, what can happen? Can anyone guess what's going to happen then? Okay, if you are having the fun of it, let me make it, let's exaggerate the effect and see what happens. See, last time even I forgot this, you just don't have to change the scale, but you also have to select the particular result over there. Label scale, nodal results, structure, design results. Okay, just a sec. Try that again. You go to animate. In animation, you have to select for section displacement or deflection. First, we'll go for deflection to see the exaggerated effect. We'll go to deflection and go to scale and reduce our scale to 0.1. And let's see what happens. So isn't it fun to see your structure that way? I mean, ridiculous structure. Seriously, who's going to design a structure like that? Even though I exaggerated the effect, the point is you can see your structure behave in a particular under the action of these forces. Yeah. Now, not just for deflection, you can go for sectional displacement as well, and you can see the effect yourself. Isn't that funny? I mean, it's seriously, that's funny a lot. Okay. Now, not to see this exaggerated effect, you can close it anytime you want. Just go to scale and you can change the particular scale of that thing. Okay, I'm increasing the scale to the normal scale to see the effect and animation tab, deflection and see the normal deflection. Okay, it's quite cool. So we have seen under animations, but what about the people or as we civil engineers go, who want to see the effect as in you want to see the SFD and BMD of the beam and how the structure is performing. So what we're gonna do is we're going to beam. In beam, as I explained before, there are two tables. Just a sec, there's some issue. Okay, we are back. So when you go to Beam, you have these different options of graphs, stresses, and forces. I'm clicking on forces. You get to see the different study of the nodes and the envelopes and the displacements and reactions on the particular beams under the action of these forces. You can also go for stresses where you can see the SFD and BMD of whole structure, or you can choose one particular beam and see its SFD and BMD. But what I am more interested in, I'm interested in graphs. So what you want to do in this is you select a particular beam and you're going to see its structures performing all the characteristics as in their SFT, BMD, and how they are going to perform in different directions as well. Not just that, you can click on any beam and column and you can see. You can see this is column, this is particular beam, and you can also find out the maximum and minimum values. Now I had issues, to be frank, I had issues when I was in second year imagining this stuff. I had issues imagining this stuff. So if you learn to use Staad, you can design any beam, give the particular set of loads, and get the SFT and BMD diagram for that. Now you have seen all different types of modes in which you can analyze your structure. You can go for a particular node and beam and get the values, or you can go for just beam and see particular beams performing. Just a second. You can see the sections and the deflection. Now, since the animation scale is reduced, you won't be able to see the deflection, but you can analyze the beam, you can analyze the structure, particularly from the beam part of it by going through these tables. Now, if you go into deep, you can also find the other stuff as in, you see here all, go for summary. In that particular summary, you get to have the maximum deflection along X direction, Y direction, all that is provided. And even envelope, as we have told you that envelope is a combination of different forces, different loads. You can also see its effect from this table. Not just beam end forces, you can go for beam force details, and here you can see the maximum axial force, maximum bending moment, maximum shear forces, and everything is provided. So you can choose the way you want to analyze the structure. You can go to nodes and check the displacement and reactions right over from there. You can go to beams. You can also go to animation if you like to see the animation of the structure, or if you want to go for the graphical analysis of the structure, go to that part and go for graphs. So you can analyze the beam that way. Now we are going to report, as in if you want to submit somewhere, you can go for report, whereas you can print the report of how your structure is going to perform under that particular road. But we don't want that for now. So we'll concentrate on the beam itself. Just a sec. Okay. So I hope you are clear with this stuff. And if you have any question, feel free to ask. Our team is ready. Our team is ready to solve your problems. Okay. Now I'm taking a 2 minutes break and I'll continue later. Thank you.
Okay, we are resuming the break. I hope you are with us till this session. So we are done with two sessions of this webinar. So we are in the final and concluding last session of the webinar, in which you are going to learn. Wait a minute, I'm just sharing my screen. In this, you are going to learn about output files and how to interpret the result. And before that, you're going to learn how to design the structure, because you haven't designed the structure yet. You might have a confusion. What does it mean by assigning the section and designing? So see, we when we assigned a section, it was a trial design. So we adopted some trial sections for the design, and after that, we are going to redesign the structure for the appeared loads and etc. So you will understand the process as we go through it. So I will just give a brief recap where we are right now. So we had in the first part we have created geometry, then we assigned sections to the corresponding members, then we have assigned supports, then we assigned respective load cases, defined load cases, then we assign the load cases, in which we have three types of load cases. One is self-fit, another is nodal load, and the third one is member load, which is a UDL. Then we analyze the structure for the applied load. We have gone to the post-processing mode, which you are seeing this window particularly. In the post-processing mode, we have learned how to check the deflections of various nodes, how to see the reactions at the supports. You can see here, these are the reactions at the support. Then we gone to the beams, forces. Then we have seen the stresses, the stress distribution diagram. You can see the angle section. These are the stress distribution diagram of that particular angle section. Then you have seen the graphs in which you have seen the PMD about Z axis and shear force diagram about Y axis as well as X axis. Then we have gone to the animation window also. We have seen the animations as well. Okay, you could see a slide animation because the scale is reduced here. So now the part comes is to designing. This is the last tab in the Staad window. You could see we have covered setup, geometry, we've gone to general, we have already run the analysis in print count, print tab. Now we are going to the final design tab. So this session, this last part of this webinar will be conducted by Pranali Nanavre. So I'm handing over to Pranali Nanavre.
Hello guys, now we are going to design the structure. So here you can see that there is a tab called current code. We want ISLD limit state design 800. So we will go to command, then check code, add. We will add member takeoff, add. I will tell you what is member takeoff. It is actual mass of structure. It is mass of structure multiplied by gravitational acceleration, which is 9.81. Actually, what is member takeoff? You can clearly understand in output file. Okay, now we will add select optimized, add. Actually, what is optimized, you will understand better in output file. Okay, take off, add. Now now we will assign this. Now you can see that there are question marks, so we'll assign the check code to whole structure. So assign to whole view, assign, yes. Now we will still member take off, assign to whole view, assign, yes. Then select, assign to view, assign, yes. Then off, assign to view, assign, yes. Now first of all, check that all these question marks are removed. That means you have already assigned all check codes and all takeoffs. Okay. Then now we will go to output file. You can see that It is Staad output file here. Open it. You can see that in right hand side there is small table. Here are warnings for us. There is only one warning. Okay. If there is in this table you can get also error, but in our structure there is no error. If you have error, then there is also software mentioning what that error is what for. Now, okay, we will go for results. There is total applied load. See that software also showing us that there is summation of force in x direction, summation of force in y direction, summation of force in z direction. There is also software output file also showing us that summation of moments about y-axis, z-axis, and x-axis. Then due to load 1 only, our load 1 was self-weight. So these are due to load 1 only. Then reactions. These are reactions created by only applied applied load number 1. Then applied load 2. Okay. I forget to assign all design. Now I am assigning. Okay. Now go for output file to minimize. Okay. Analysis. Because I have forgot to run analysis for design, so I have to run analysis again. After designing, we need to assign also, which I have forgot. Now it is analyzing. Okay. Now we will also go from here. View output file. Done. Okay. Now here is again. Okay. As we can see that applied load. We have already seen this. Reactions due to applied role, total applied role 2, total reactions due to applied load 2, applied load 3, total reactions due to applied load 3. Then we will go for still takeoff. Uh, Still takeoff. As you can see that there is still takeoff. It is a weight. It is for every member there is output file is giving length and its weight in kilonewton. That is what still takeoff. Now designing still design. Here we can see that for every member how much, as you can see that member 1 is failed. So okay, these are warnings. Still takeoff. You can find, if you want to find our fail members, go to search, type fail, and next here we can see that our member number 1 is failed. Now actually optimized section is what section that Staad itself give us optimized section which is safe for loads.
say for that load, and by knowing that optimized section we can reassign the sections to our structure so that that structure not does, doesn't fail for that load. That is the work of optimized section. uh, as you can see that the member number one is fail, and this output file is also showing us that why the member number one is fail. As you can read that one is due member number one is slender and cannot be checked for moment force. If there is any bending, then where that is the member number one is failed due to its slenderness and it cannot sustain for moment and force. Okay, then member two is also failed. See that output file is showing us why member is failed also. And as you can see here is location also. It is a location of critical position, which is critical position of member, that is from if member is from member 4 is from 3 node number 3 to node number 4, then location is showing us that from node 3 the critical section is from 3 meter. Okay. Our structure doesn't have any error, so there is no error. Results. Okay. So in output file you can get to know which member fails and which section is to be assigned, so assigned to failed member. Now I will hand over the session to Sumit.
Hello, participants. I think today's session was a very good session. So we have covered till output file. Can you see the output file again? I hope you have understood how to read the output file as well as how to interpret the results. Basically, this output file is the summary of your entire structure. It's basically a design basis report. So from output file, I'm closing this output file. So in the third section, you had something called, you realize that your structure is failing at some points, some members. So the Staad has given the optimum section for those particular members. So what you need to do from here onwards is, suppose I will again go to the output file for that. I'm going to the output file. I'm going for steel design. You could see here, member number one. You assigned initial section as 45 by 45 by 5 and it's failing. And what Staad suggested the section as 135 by 65 by 8. So what you need to do is go to again, where is your member, beam 1, here is your beam 1. Assign this beam 1 the new property section which Staad has just suggested. So again, we will go to general. You can check here, you can click on this member, you could see here, geometry. If you go to the property, you could see it has assigned ISA 45 by 45 by 45. But Staad has suggested a different optimized section. So what you need to do is assign this, already this optimized section, ISA 35 by 65 by 8 is created in this section gallery. So you just need to assign this section to this member. Again, after assigning this particular section to this member and the remaining sections, which is, Staad has suggested some optimum sections to the respective members. So assign those optimum sections to their respective members and repeat the process of analysis and design again. So basically, to design particular structure, it is a iterative process. In this iterative process, you will obviously fixed with once you fix with your geometry, you need to play up with properties. Again, you need to analyze by applying loads. Then you will go to design command. You will give some commands in the design like select, take off, etc. And then you will select the code in that design command. Because we are using Indian codes, it will be IS 800 2007, which is for limit state. And you will come up with the output file, and Staad will suggest the optimum sections. So reassign those optimum sections. Again, follow the same steps of analysis and design. At the end, after some iterations, depending upon your type of structure, you will end end up with the best possible outcome of the design, in which all the members will be safe and every member will be an optimum section. So this is what you need to do in this competition also. So our competition is based on creating a nice geometry which will give the least possible shear forces and bending movements in the analysis, so that we can assign the optimum sections, and at the end, if we assign the optimum sections to the best possible geometry, your structure will be optimized. So what do you mean by optimum structure? Optimum structure in basic industrial level, you could just, in layman terms, you can understand it as simple, the structure with the least dead weight or least self weight. So how you'll see the self weight of the structure? That's why we have put in takeoff command in design. So whatever values Staad gives for takeoff is the self weight or dead weight of the structure. So there are some other parameters also. Obviously, your structure should be safe. That's the qualifying parameter. There are some other parameters like serviceability criteria, deflection criteria, and lateral drift, etc. So we are going to cover these parameters in the next webinars, which will be focused on particularly tower design, transmission tower or telecommunication tower. So today we are concluding this webinar. I hope you liked our webinar and you enjoyed it. I have some instructions before concluding the webinar. Please install the software as soon as possible. Don't waste your time. And if you have some queries, you could post it on your respective WhatsApp groups. We have created mentorship programs also. Wait a minute. I think no, everything is fine actually. Oh, can you hear me? Huh? Okay. I thought there are some sound issues. Sorry. So I was going to give you the instructions. So in the instructions, you need to firstly install the software properly, use it, practice a lot, go through all the webinars from Start session 1 to this current webinar. So today we have covered up till recap everything, and we have also covered up all the re-webinars also. So from today onwards, there will be no particular Staad session basics webinar. From here onwards, next webinars will be focused on telecommunication tower design or transmission tower design. So please be ready for that. Be prepared. Gear up yourself for the competition. This is going to be an exciting and fun ride for all you people. Don't miss this opportunity to learn something new. On this note, I am concluding this webinar. If you have some issues, please post it in your respective mentors group or on our FB page. And for updates, please follow our FB page, because we're going to put up a lot of things on the FB page. It will be easier for you to get the updates as well as from our side. So don't miss out on any updates. Follow our FB page. Stay active on your WhatsApp groups, and enjoy this learning of Staad Pro, and get ready for the exciting competition. Okay, thank you.